Hi friends, today I will explain the architecture of Snowflake and what are all the layers present in the Snowflake architecture and what is the functionality of each and every layer. So let's discuss about the Snowflake architecture. What are the layers present in Snowflake architecture? What is the functionality of each and every layer? We'll discuss in detail. Okay. So if you look at this diagram, this is the architecture of Snowflake. So remember guys, this is very important. If you want to learn Snowflake, okay, and if you want to attend for interviews, this is very important. This is the very basic thing. You have to understand the architecture of Snowflake properly. Then only you can answer the questions. Even you can understand the concepts very good. Okay. So Snowflake architecture contains three layers. Let's come from bottom. Okay. The bottom layer is a storage layer where the actual data will be stored. Okay. And the next layer is query processing layer. This is like CPU. So whenever we run our queries, they will be running with help of virtual warehouses. This is the actual processing unit of Snowflake, where our queries will be executed and where our compute cost will be calculated. So everything will be in the query processing layer. And there is one more layer, cloud services layer. Okay, this is like brain of the Snowflake architecture. Like it will maintain everything, even though data is stored in the database storage and queries will be executed by virtual warehouses, but everything should be organized by cloud services layer only, like authentication and access control. That means whenever you put your password, user ID and password, you should be able to log into your Snowflake account, right? So that the authentication process will be taken care by cloud services layer. And access control. So if you want to the same by using username and password, or by using some other way, if you want to put access control over the account, okay, that will be taken care by cloud services layer. And infrastructure management. Okay, so as I said yesterday, so in cloud services, okay, there will be no infrastructure management. It will be taken care by Snowflake by default. Okay, so cloud services layer of the Snowflake architecture will take the infrastructure management thing. And the optimization, okay, query optimizing and metadata optimizing, everything will be taken care by cloud services. So what is meant by query optimizer, what is meant by metadata optimizer, we'll see in the uh, whenever we are discussing in detail about them. Okay, and the metadata management is one of the very good feature available in Snowflake, and it will be taken care by cloud services. And the security, so at the end of the day, the data security is very important. Even the security part will be taken care by cloud services layer. So we cannot do anything here on this top layer. We cannot do anything. Snowflake will take care of everything. So the cloud services layer of Snowflake will take care of this thing. Okay. So we can do here only. We can store the data in the storage layer, and we can execute queries by using virtual warehouses. So these two things we can control, but this thing will be handled completely by Snowflake. We don't need to bother about this one. Okay, so let's see in detail. So what is the database storage layer? What is the storage layer of Snowflake? Okay, how the data will be stored here, we'll see. Okay, so storage layer, it will store the table data and query results. So whatever the data we are inserting into the tables, okay, that will be stored in the uh, storage layer. As well as there is some concept of cache and materialized views, where the result sets or the query results will be stored temporarily, okay, or permanently. Okay, even those query results will be stored in the database storage layer itself. Okay, so here the data will be stored in the columnar format, unlike other traditional databases like Oracle or MySQL or Teradata. So here the data will be organized in columnar format, not row oriented. We'll see how it will be in the next slide. Okay, and here the data will be stored in the micro partitions. So if you see here, in the storage layer, it contains so many, like number of micro partitions. The data will be stored as a compressed data, and it will be stored in the micro partitions. And Snowflake manages all aspects of how this data is stored. Okay, so you don't need to worry, like so you don't need to select any micro partitions. So by default, if you just insert any row into the Snowflake database, so Snowflake Cloud Services layer will handle. Okay, so by using some metadata management or some other features, so it will take care. So which row will be stored in which micro partition, all this thing will be taken care by Snowflake itself. We don't need to bother. Like so these things like data organization, what is the file size, okay, what is the structure of the table, compression, so it will apply some compression algorithms over the data so that less space will be occupied. Okay, and the metadata management and the stats of the table. Suppose if we are loading some data into a table, okay, some metadata will be managed. So metadata statistics means so how many number of records stored in the table, what is the minimum value, what is the maximum value, what is the range of value stored in the micro partitions. Okay, everything will be taken care by Snowflake. We don't need to bother. So you just insert the record and the Snowflake will take care where to insert, what is the micro partition, what is the cluster to apply. It will take care everything. Okay, so we'll see that in detail while discussing micro partitions and clustering. Okay, so the data objects stored by Snowflake are not directly visible nor accessible by the customers. Suppose we have a table, okay, and we have inserted some million records into the table, but you cannot visually, you cannot see the table anywhere, right? So it's a object, okay, it's a object in the database. Table is a object in the database, but how can you see the data? Okay, so you cannot see this data or you cannot access the data, okay, but directly, but we can apply SQL queries, we can prepare SQL queries and we can run SQL queries. They are only accessible through SQL query operations, those run using the Snowflake. So by using a query processing layer, we submit SQL queries. It can be a select query or it can be a DML query. So if you want to select the data, if you want to fetch the data, or you want to operate the data, or you want to remove some data, whatever the operation, okay. So we can do by using SQL queries. Otherwise, we cannot directly see these objects in the database. Okay, and we can define cluster keys on larger tables for better performance. So if you don't maintain any clusters, or if you just simply inserting the data, suppose my storage contains some 100 micro partitions. So by default, whenever you insert row 1 will be stored in the micro partition 1, and row 2 will be stored in the micro partition 2, like that until the first micro partition. So we have to define some size of micro partitions, and until that first micro partition is completely filled, it won't go to second micro partitions. Okay, but there is a concept called clustering. So if we define clusters on table columns, how the data will be organized, that is very important. We'll discuss in detail in the next sessions. Okay, so whenever you apply some cluster keys, based on that keys the related data will be stored in one micro partition. So that whenever, suppose I have a column called country, okay, I have multiple countries customers data, and whenever I define cluster key on that country, okay, so all the similar country data will be stored in one micro partition. Suppose there is Indian customers data, and all Indian customers data will go to one or two micro partitions, okay, based on the size of data we are loading. And whenever you run some query like select star from the table where country equals to India, what it will do, instead of scanning all the storage area, it will fetch only data from that micro partition where we applied that cluster on the country field. Okay, so whenever we apply the country field, what will happen, the data will be stored in only some micro partitions. So whenever we apply that filter where country equals to India, instead of scanning all the storage, okay, it will fetch only the data from particular micro partition. So the query performance will be very good. So even this cluster management will be done by Snowflake itself. Okay, you just have to define some cluster keys, and whenever you insert some data, it will take some time. First time whenever you insert the data, it will stored, okay, it will be stored in the micro partitions, and based on the cluster key we are defining, it will realign the data. Okay, so first time at the time of inserting, it will be just stored like that, but within some time, it takes some 5 to 10 minutes after storing the data, but it realign all the data. We'll see that. I will show you that in practically. So whenever we insert some million records into a table, how the data will be stored first. Then after 5 minutes, how the data will be stored in the micro partitions, how it is internally organizing, I will show you practically by using some queries, SQL queries. Okay. So this is about database storage layer. This is very important. In many interviews, you will get a question how the data will be stored in storage layer. So what format they are asking. So you have to say the data will be stored in the micro partitions in the columnar format. Okay, they are expecting the answer like columnar format because most of the traditional databases they store the data in row format, right? But here the because of columnar format the performance will be very good. Okay, so this is the important thing. You have to specify the data will be stored in the micro partitions and it will be stored in the columnar format. Okay, so for example this is the data. If this is the logical structure of a table, suppose my table contains type, okay, name, country and date, four fields. Okay, and in the traditional databases the data will be stored like this only, row oriented databases, the data will be stored like this and this is the logical structure. But when it comes to the physical structure in Snowflake, okay, how this will be stored. Okay, so like this the data will be stored. If you see particular record, okay, so here it contains 6 rows. Okay, suppose if you see 2a uk 11 by 2. Okay, you observe my mouse. Okay, 2, okay, sorry, 2a uk 11 by 2. So this is one column. And if you see 4c sp 11 by 2, 4c sp 11 by 2. So this is one row again. But even though the logical structure is like that row oriented, but whenever you select the data from this micro partitions, okay, you just select star from this table, it will display like this only. But internally it will be organized like this columnar format. Okay, so if you store the data in the columnar format, so what they are saying, what Snowflake is saying, the performance, they observed lot of improvements in the performance of the SQL queries. That's why they opted for columnar storage. Okay, so the data will be stored like that. So suppose this is one micro partitions where 6 rows stored, and this is another micro partitions where another 6 rows stored. Like this there will be number of partitions in the storage layer. Okay, so the data will be organized in the storage layer in the columnar format like this. So this is just a sample diagram. So we'll see with the help of diagrams while explaining about the clustering. So if you define a cluster key, how the data will be stored in the columnar format. If you don't apply clustering, how the data will be stored, we'll explain clearly. Okay, at that time. But just remember, so in Snowflake, the data will be stored in micro partitions in the form of columnar format. Okay, so or you can say Snowflake is a columnar storage. Okay. So the next thing is query processing layer. So I told right the first layer is database storage layer and the second layer is query processing layer. Okay, so this is the actual processing unit of our Snowflake. Suppose if you take a computer, there will be many parts in the computer like a keyboard, mouse, CPU. But what you will say, CPU is the central processing unit which will process, okay, the things or the tasks. Like that here, this query processing layer is like CPU. Okay, it will process all our queries. So if you want to run any of your queries, you have to first define virtual warehouse. You have to create a virtual warehouse, then the virtual warehouse will execute the SQL queries. Okay, it can be a DDL query, DML query, select query, anything. It will be taken care by it will run through virtual warehouse only. Okay, so the query processing layer is the actual processing unit of Snowflake. Snowflake processes queries using virtual warehouse. This is very important again. So they will ask you how the queries will be executed in Snowflake. So you have to say by using virtual warehouses. We'll discuss in detail what is a virtual warehouse means later in this session itself. Okay, but virtual warehouse will only be executing our queries. Each virtual warehouse is composed of multiple compute nodes allocated by Snowflake from a cloud provider. Okay, so we discussed yesterday. So whenever we are hosting Snowflake, we can host in any of the three cloud storage providers like AWS or Azure or GCP, right? So if you choose AWS, then what will happen? and AWS, they are group of EC2 instances. Okay, so AWS will give some EC2 instances. They are like the processing compute nodes. So here you can see, right, each virtual warehouse is composed of multiple compute nodes. In case of AWS, these EC2 instances, EC2 servers are the compute nodes. But in case of Azure, so if you host your Snowflake account on Azure, then it will be virtual machines. Okay, these multiple compute nodes are virtual machines. Okay, it's based on the cloud storage where you are hosting your Snowflake account. So that cloud provider will assign some servers, okay, processing servers as compute nodes to the Snowflake, and our queries will be executed by those compute nodes where the compute nodes will be available on the in virtual warehouse. Okay, so compute cost will be calculated on the basis of query execution time on virtual warehouses. So at the end of the day, the cost is very important, right? So how the cost will be calculated? Suppose I have created a virtual warehouse of size small. Okay, S size warehouse I have created. I am running queries on by using that S size virtual warehouse. Okay, so finally at the end of the day, the cost will be calculated on cost will be calculated for each and every minute we are running the queries on the virtual warehouse. Suppose if you are running a query for 5 seconds, then the minimum billing is 1 minute. So it will be calculated like the query executed for 1 minute. Suppose if you are running for 30 minutes, okay, only for the 30 minutes cost will be calculated. Okay, so this cost calculated based on the virtual warehouse, okay, on the basis of query execution time on the virtual warehouses. We'll show you this while explaining the practical sessions. Okay, the lab sessions will show you how this will be calculated. Okay, so whenever we are running some queries on virtual warehouses only for that time, okay, so Snowflake will charge the credits. Okay, and the credit value is based on dependent on multiple factors like region, okay, and the Snowflake edition. Okay, so there are many other things. We'll discuss all those things while explaining pricing in Snowflake, cost in Snowflake. Okay, so but just try to understand query processing layer contains virtual warehouses, and they are the actual processing units of Snowflake where our queries will be executed. Okay, that's it. And virtual warehouses are considered as the muscle of the system. So while cloud services is the brain of the system, so this is the brain of the system. This will take care of everything. But this is the query processing layer is the muscle of the system. So if you want to do any physical task, okay, so your brain has to send instructions. Okay, do this, take this thing, do that work like that. But at the end of the day, so who has to do? Like your hands has to do, your muscles has to do, right? So queries will be executed finally on the query processing layer. So we call this as the muscle of the Snowflake. Okay, so while cloud service, it will be only sending instructions, it will not do anything. Okay, but the instructions will be processed by query processing layer. So whenever user executes some query, okay, what will happen? uh, the query will go to this database storage layer, and it will fetch the data from storage layer. So if all the three services working properly, then only user can do data operations like select or insert or delete, whatever it can be. So cloud services layer will send the instruction, and this will query processing layer will process those instructions by fetching the data from storage layer. Okay, so I hope you understand now. Okay, so this is the cloud services layer. We'll discuss in 2 minutes. Okay, it will send the instructions, and query processing layer will process those instructions, and based on the query we are running. So if it is a simple select query, it will fetch the data. If it is a DML query like insert, update, delete, it will do certain operations on the database storage layer. And suppose I have selected extra small warehouse, and in future my data size is growing. Okay, so we have a facility like at any point of time in future we can increase the size of the virtual warehouse. So that process we call as scale up. Okay, so we can scale up and scale down easily. So if you don't know what size you have to choose, and by mistake you have chosen large size, or by wantedly you have chosen large size, but after some time you realized large is not required, so medium will work for me. So you can easily scale down your virtual warehouse size, okay, at any point of time in future. Okay, and there are features like auto suspend and auto resume available in query processing in the virtual warehouse. So while creating the virtual warehouse itself, okay, you have to choose auto suspend and auto resume. Okay, auto suspend time you have to choose. By default, it is 10 minutes. That means if no queries are running on your virtual warehouse, it will be suspended after 10 minutes. Okay, so that it will be idle and there will be no charge for that virtual warehouse. Okay, and whenever if you enable auto resume, no need to resume the virtual warehouse manually. If you just run a query, it will be resumed automatically. So we'll show you how to enable auto suspend and auto resume tomorrow, okay, while creating the virtual warehouses. But this is one of the very important feature, auto suspend and auto resume. Okay, so this is about query processing layer. Let's go to cloud services layer, which is very important because this is the brain of our Snowflake. So this cloud services layer is a collection of services that coordinate activities across Snowflake. So whatever the action we are doing, okay, so that should be, it's like instruction, like suppose we are humans, we have to do certain tasks every day. But if you want to do that, you cannot directly do that, right? So your brain has to instruct, okay, get up from the sleep, take your brush, okay, uh, okay, go to bath, okay, take your breakfast, go to office. So those instructions will be processed by the cloud services layer only. So here also in the Snowflake, it is a collection of services that coordinate activities across Snowflake. Everything will be taken care by the cloud services layer of Snowflake. Okay, so this is the part. Okay, and we call this as the brain of the Snowflake. And what are the activities it will take care? Okay, so like authentication and access control, like that login in. So we can with for one Snowflake account we can create multiple users. Suppose there is one organization in the real time, they are doing some project and they have some 10 members team. Okay, so but they cannot go for 10 Snowflake accounts, right? So they will create only single account, okay, Snowflake account, and in that account they will create multiple users. Like if their team size is 10, they will create 10 users in the same Snowflake account. So for the 10 users, there will be 10 user IDs and 10 passwords, right? So those, and if they want to log in, they have to log in with their own user ID and password. So all this authentication mechanism and access control mechanism will be taken care by Snowflake. Okay, and infrastructure management. Okay, as I told, right, in the traditional databases, infrastructure management, like you have to purchase some memory, okay, you have to purchase some RAM, okay, and you have to purchase like some SQL tools, like what are the tools we have? Teradata SQL Assistant, okay, DB Viewer, okay. There are so many SQL tools. You have to purchase them, and you have to install some drivers. Everything you have to do, okay, by manually, or the organization admins will do. But here that is not required. Okay, you just log into the account and you can run your queries simply, because all the backend infrastructure management will be taken care by, okay, Snowflake itself. In the Snowflake cloud services layer will take care of all that infrastructure management things. So we don't need to bother about this thing as well. And the metadata management. So you remember this word, this is very important in Snowflake. So many things will be done by metadata management only. Okay. So whenever we are inserting some data into Snowflake, it will maintain some statistics. Those are called metadata statistics, like how many rows you are inserting into the table. Okay, what is the minimum value in that column, what is the maximum value in certain column. Okay, so all those things will be taken care by the cloud services layer of Snowflake. So we call that as metadata management. So let me explain a single example, okay, simple example, how you can understand. Suppose I have 100 million rows in a table. Okay, I have inserted 100 million rows into a table. And when you say select count of star from the table, in general, in the traditional databases, what it will do? Okay, it takes a lot of time because 100 millions of records are there. it has to scan all the table. Okay, and suppose it is giving the result in 2 or 3 minutes, right? But in Snowflake, what will happen, as metadata is maintained in Snowflake? Okay, so it will store one field called number of rows in the table. So instead of scanning all the table, okay, our query it will not scan all the table, because the metadata is available for the table, and that metadata contains how many rows stored in the table. So it will simply bring the data from metadata layer. Okay, so from metadata it will bring that row count and it will display in microseconds. Okay, so hope you are understanding. For every table or for every schema, so everything, some metadata will be managed. Suppose if you are creating some views, or you are creating some materialized views, so for everything some metadata management will be there. That metadata management will be taken care by cloud services layer. So how the data will be fetched from metadata by using metadata, will show you in practical. So whenever we run some queries in Snowflake, what will happen? So we can see from where it is fetching the data, how many partitions it is scanning the data. All these things we can see in the web UI of Snowflake. Will show you all those things. Okay, how the data is scanned in the micro partitions. Okay, how many micro partitions it is scanning, what is the data flow. Suppose if you apply filter conditions, join conditions, group by operations, so in which order they will be executed, and within how many seconds it is fetching the data. Okay, everything we can see in Snowflake web UI. So while explaining those things, I'll show you in practical. Okay, so metadata management will be taken care by cloud services layer. And security. So security is also very important in Snowflake, right? So suppose any organization is purchasing a Snowflake account, okay? So they don't need to bother about how my data will be stored in Snowflake, how securely it will be stored. You don't need to bother. So the cloud services layer, by using this authentication and access control mechanisms, it will take care of your data. It will be stored securely in the database storage layer. Okay, so we don't need to bother. Again, the cloud services layer will take care of that security part. And it manages, so cloud services layer manages all serverless tasks like Snowpipe tasks, materialized view maintenance. There are some other things. Okay, so these are some of the serverless tasks. That means we don't need virtual warehouses to run Snowpipe, or to run it, to create a task, or to manage the materialized views. We don't need virtual warehouses. So those things will be taken care by the compute resources offered by Snowflake. That means it will be taken care by the cloud services layer. So anything, suppose if you want to run some Snowpipe, or if you want to create a task, some resources needed, right? So those are not our resources. Okay, these are our resources. Virtual warehouses are our resources. But for these operations, these virtual warehouses will not be consumed. So Snowflake will give their compute resources, okay, for these serverless tasks, okay. But there will be some charge for those serverless tasks, and it will come at the end of the month. It will be coming in the bill, okay. So that bill will go to the organization who is the admin of that account. Okay, suppose we are creating some trial account, right? After 30 days you cannot use your trial account. So if you want to continue your account after 30 days, you have to provide your credit card information. Okay, based on the consumption, based on the data you are storing, and based on the queries you are running for the next 1 month, the bill will be generated. Okay, it will come in your credit card bill. So if we are doing some transactions, what will happen in real time? Okay, at the end of the, by using credit card, you are purchasing something and you are doing some online transactions. What will happen at the end of the day? You will get a credit card bill, and there you can see all the things like that here also. So if you want to continue a trial account after 1 month, so you have to put your credit card information, and bill will come at the end of the month. Okay, like that. Okay, so these serverless tasks will be managed by the cloud services layer of Snowflake. Okay, so I hope you understood all these three layers. This is very important. You just remember this flow. Okay, so all the instructions will be given from cloud services layer, and those instructions will be processed by the query processing layer by using virtual warehouses. And if you run some query by using virtual warehouse, so it will scan the data, or it will do some data operations in the database storage layer. Okay, so this is the flow. Okay, so now this is important. So we have Snowflake account, I have stored the data, but how can I connect to that data? How can I retrieve the data? So what are the ways I have to retrieve the data from the Snowflake storage layer? Okay, so Snowflake support multiple ways for connecting to the service, like a web-based user interface from which all aspects of managing and using Snowflake can be accessed. Okay, that means, so I showed you yesterday, right? So we have web interface where we can see all our database objects. Okay, and we can apply some queries to see the data. Okay, so that is the web UI offered by the Snowflake itself. This is one way how you can access the data from storage layer. And the second way is there are some command line clients. Suppose NoSQL is one of that. Okay, this is a CLI, command line interface. NoSQL is one of the CLI. Okay, where you can install NoSQL and you can run SQL queries on the NoSQL client. Okay, so we'll show in one of the session. I'll show you how to install SnowSQL, how we can run queries. Okay, on the Windows itself. So without logging into this Snowflake account by using web UI, so just on our desktop, so we can connect through SnowSQL and we can run our queries there. Okay, I'll show you this in practical. And there are some ODBC, JDBC drivers, okay, that can be used by other applications. Suppose I have visualization tools or reporting tools like Tableau or Power BI, and from the Tableau, I want to connect to Snowflake at the backend, and I want to generate some reports. So for that, what we have to do, we have to install some ODBC, JDBC drivers. Okay, so those JDBC drivers will help you connecting with the Snowflake account, and you can access the data from Tableau. Okay, so this is one way. And through native connectors available in ETL tools. Okay, suppose we have ETL tools like DataStage and Informatica. So by using the connectors, okay, suppose in DataStage we have a connector called the Snowflake connector. By using that connector, we can give our account URL, username and password, and we can log into Snowflake and we can run our queries there. Okay, so these are different ways of connecting Snowflake, or these are the different ways of accessing the data from Snowflake storage layer.
Thanks for watching. Please subscribe to my channel.